My name is Navin Sharma. I'm the head of product here at Stardog, and I'm here to talk about our really top of mind topic for not just us here at Stardog, but a lot of folks, a lot of companies that are actively looking at ways to bring the promise of Gen AI into their own enterprise organizations. Obviously, keeping in mind that ultimately it's about accuracy, explainability, and trust as the basis of how this will bring value to your own organization. So we'll get started for the sake of time. For us, we do believe very strongly in the fact that the winners in every industry, no matter which industry you work for, will be companies that empower every knowledge worker with data and AI. Many of you have probably already heard the saying, English is now the hottest programming language out there. And that is essentially how companies will look to enable enterprise access to enterprise data in ways that any knowledge worker inside the enterprise, without requiring any specific skill sets for SQL or Python or Java or whatever, can be in the best position to drive more data-driven insights and decision making. Of course, this means, and this is backed by someone like Gartner, that Gen AI will have a major impact in ways that companies and, frankly, vendors with tools will start bringing more conversational AI interfaces into the organizations, which will be embedded in about 80% of those offerings by 2025, which is up 20% in 2023. By 26, they'll likely be more than 50% of all enterprise applications that will have some form of conversational interface, which you can kind of see a drastic increase from where it is today with less than 5%. And by 2028, no surprise that, again, conversational applications will provide advisory and intervention roles for about 50% of knowledge workers, which is very exciting, especially in lieu of the vision that I painted in the previous slide. Is going to be a critical enabler for organizations to be more data-driven. Finally, the notion of democratizing data to large swath of users inside their own enterprise. There is a poll out there. If you get a chance, definitely would love to understand how you guys are thinking about bringing Gen AI inside of your own organization, especially with respect to making it work with enterprise data. We'll leave the poll out here for a few more seconds. I see that currently most of you have started considering it or are using it already at a rate of almost 40%. And about the same amount, 40% of you are planning to use it within the next year. So it's a good chunk, about 80% of you that have now participated in this poll reflect the fact that you're either currently using it, considering it, and or planning to use it within the next year, which certainly aligns with my conversations, across a lot of these customers as well as clients and prospects, and even certain events that I've now recently attended stayed essentially the same, sort of have the same dynamic in place. So it's definitely an exciting time to be in this place where companies are going to start bringing the value of Gen AI inside of their own enterprise, which is great and exciting in general. So what does that translate to when we think about our own organization and how we might consider getting data ready for AI? Well, the challenge, of course, is that deep insights are certainly still limited by not only the fact that the data is fairly fragmented inside of large enterprise organizations, but there are other aspects that to consider when you think about bringing Gen AI and delivering that at scale, right? Costs is a big one for companies, lack of skills, certainly choosing the right technology, architecture, and infrastructure to enable Gen AI is a big challenge and remains a big challenge. And when we talk about data and the fact that data is fragmented, add on top of that the fact that data often lacks business context, and business meaning is not fully understood by the people that need to make decisions, which is basically the knowledge workers that we just talked about. Ultimately, AI hinges on the knowledge that is needed for the enterprise as a whole to enable Gen AI for use with their own enterprise data. So when we talk about AI hinges on knowledge, what does that really translate to? Knowledge of enterprise data and metadata. Like, how do we understand what data is available, what the data means? How do we discern the difference in how we define the same thing in multiple ways inside our organization? So the fact that a lot of this enterprise data and metadata, despite the fact that it is siloed, is also not fairly well harmonized and understood through meaning. And this is where we've seen Gartner again talk about the impact radar from a generative AI perspective. The knowledge graphs are the critical component from a build and data related capability and technology for organizations to think about bringing into the enterprise, especially with regard to the fact that, ultimately making data machine readable data structures that represent semantic knowledge of the physical and digital worlds will only be driven by the fact that a knowledge graph sits right on top of your enterprise data to provide that structure to make it more machine readable and ready. And so that's a big part of your build, your data, making your data AI ready is the notion of a knowledge graph that sits on top of your enterprise data to provide and represent that semantic knowledge, that semantic meaning. Now, when we talk about knowledge graphs, it's important to understand, what are some of the critical capabilities of a knowledge graph platform, right? So we think about it from the context of oftentimes graph databases by themselves don't represent what Gartner talks about, and frankly, what the industry talks about from a knowledge graph perspective. Graph databases represent another data silo. Imagine that you have all your data in a data lake, and imagine that you have your data in an MDM system. And do you really want to move and copy that data to create another database silo through which you want to communicate and operate your GenAI application? So it's important to understand when we talk about knowledge graph platforms, what we're talking about is this notion of a semantic data model that is abstracted away from how the data is physically structured or where it's stored, and represents sort of your business information model, your business ontology, your business concepts and the relationships between those business concepts, so that you capture that business context as a representation of that semantic data model. So that's one important aspect of the distinction, where the semantic data model is abstracted away from how and where the data is physically structured and located. Secondly, when we talk about an enterprise knowledge graph platform, it's also important to understand that you want to leave data where it sits. You've done the hard work of bringing data into a data lake. You've done the hard work of migrating data into your enterprise cloud data warehouse, or the very fact that you have data sitting in your applications. The last thing you want to do is to copy and physically move that data into another database layer. So enabling a federated querying approach where you virtualize access to a lot of that information inside of your enterprise in ways that does not require you to copy and manipulate data every time you need to answer a business question is an important aspect and a critical capability of an enterprise knowledge graph platform. And then the last bit is this notion of inferencing, right? So how do you generate more connections to further enhance and take advantage of this network effect that lives inside of your own enterprise data? So the idea of understanding sort of logical reasoning, where A equals B, B equals C, so A equals C, and applying more business-centric rules or business logic on top of that semantic data model, so that you can infer new meaning, you can infer new relationships without having to reshape the underlying data where it lives. So being able to create new knowledge on top of your existing data and existing data structures by applying business logic layer on top of your semantic data model is another aspect and a critical capability that comes along with an enterprise knowledge graph platform. The other aspect where we say AI hinges on knowledge is the fact that it's the knowledge of your business and your domain that can be trusted. And that's an important distinction to make here as well. I know we talk about, and Gartner talks about the fact that knowledge graphs in their emerging tech impact radar of 2024 are also the critical enabler for companies and organizations to bring in conjunction with large language models to essentially, and let me close this out, of the applications pulling in here, essentially deliver trusted and verified facts to their outputs. Now, this is an important part of bringing GenAI inside the enterprise, is how do you ensure that the data and the information that is being retrieved or presented back to your knowledge workers can be trusted and verified as facts to the outputs that are getting generated. And so having knowledge graphs be a critical enabler in that GenAI architecture becomes an important aspect of the overall solution that you deliver inside the enterprise. And again, we know this for a fact that ultimately many companies have already started to consider and are considering the approach that has now gained some popularity called RAG architectures, right? So retrieval augmented generation and the utilization of vector databases that sit on top of your large language models. The problem with that approach, of course, is one, the fact that large language models in that scenario serve as the foundation to the source of truth. And that is okay if you want to know, if you want to have general knowledge about the universe and the world around you. And even then, we understand that that oftentimes creates a lot of hallucinations in terms of the generated response, because ultimately what are GenAI, what's a large language model and its purpose in life is essentially generating content in terms of a probabilistic approach. And so, yes, the adding a vector database on top might give you some better filters. You can obviously identify nearest neighboring concepts so that you can get better and smarter in terms of the answers that come back, but you do not put yourself and your organization in a place where you can still drive accuracy, explainability, where and how that response was generated, and more importantly, the business context. And so that's where enterprise knowledge graphs really lend themselves well. For one, they provide the right guardrails. So everything in terms of a response is driven by this sort of semantic data model, which acts as the guardrails to what can or cannot be responded to within the context of the business and the business domain. So you know that whatever answers you're getting are driven by that trusted data model that drives that business meaning and business understanding. There's full traceability and lineage because the semantic data model maps itself back to your source of truth. So your source of truth lives inside of your enterprise systems, inside of your MDM system, inside of your data lake, inside of your application like Salesforce. And so being able to have that traceability and lineage back to that source of truth is an important aspect of the value that you get when you work with enterprise knowledge graphs in terms of a safe model and a safe architecture for generative AI. And then last but not least is the ability to provide a better domain knowledge or business context lens on top of your enterprise data. So when you are enabling your knowledge workers to communicate ways in context of their use cases or in terms of the specific business scenarios for which they're tasked, their representation of information, their communication style, and the way they want to ask questions is best encapsulated in that semantic data model as well. That's part of the enterprise knowledge graph. So important that you make that distinction when you think about deployment of GenAI against your enterprise data, that RAG architectures, vector databases just do not address a major gap that exists with respect to accuracy, explainability, and frankly, hallucinations in general. And then the last bit is this knowledge of large language model system integration and doing that at scale inside of your organization. Now, if you are a big organization that's willing to invest hundreds of millions of dollars to try fine tune and train your own large language models against your own domain and your data, great. There's a big chunk of the organizations in the enterprise that cannot afford that kind of expensive infrastructure, as well as just the pure costs to bring something like that internally. So the challenge, of course, is to address these issues with respect to time and in terms of time to value, in terms of costs, and in ensuring that you don't blow away all budgets. And then third and not least is the skill set. Can you bring the requisite skill set to bear within your organization to deliver on the promise of Gen AI? And we see this, this problem is definitely getting even more harder for large organizations, especially as you start to think about the number of new models that are now getting created and generated, from small models to large language models and everything in between. Over 250,000 plus Hugging Face models for you to choose from, over 25 plus and growing GPU chips and infrastructure, hardware coming from the likes of NVIDIA and AMD and Supermicro. And ultimately, OpenAI is a black box. Can you really trust everything with one vendor and with all your data in the future? And then to top it all off is the fact that you're now dealing with over trillion plus. Think about enterprise data and the landscape that exists in your enterprise, records, the amount of data that's available, and it's just going to continue to grow, right? With every click stream that you capture, that data will only become more complex and harder for you to manage. So how do you work through sort of this dynamic of choosing the right large language model, figuring out the right orchestration process, figuring out the right infrastructure, ultimately to deliver on the value and the accuracy and the performance that you need at scale? And that's where we've been hard at work to bring to the market a first of its kind offering for conversational data, which combines the benefit and the value of what we just discussed around enterprise knowledge graphs with the combination of generative AI capabilities that enable universal access through a large language model powered user experience for any knowledge worker in the enterprise to answer questions related to their data in the context of their business scenarios, and do so in ways that gives them timely, accurate, and explainable answers that are secure and hallucination free. So I know that's certainly a mouthful, and I'm presenting. It almost feels like a holy grail here, but it is important to understand, first and foremost, that this is an important aspect for any company that's going to bring generative AI and make it work with your enterprise data, is some ability to put these guardrails in ways that are secure, safe, and hallucination free. And we do believe, and it has been backed by others as well in the industry, including Gartner, that combining the power of enterprise knowledge graphs and generative AI will be the way you make that possible. And so I'm going to give you a quick demonstration of what that technology looks like in action. Ultimately, from a pure user experience, I would expect you to think of it just like any other conversational interface. But what's important and what's driving this is your enterprise data presented in the context of your business domain in ways that does not have a black box approach to it, but full explainability and traceability behind every answer that is provided to the question that gets asked. So with that, I'm actually going to transition over to a quick demonstration so you kind of see this in action, and we'll come back to a bit more of the how do we make this work behind the scenes, and how does this all work together. Before I do, and I do want to highlight typical use cases where we're seeing a lot of this being deployed, a lot of interest growing in specific industries. Obviously, this is not necessarily a full list of all industries, but think about where the knowledge workers really are hungry for information that drive some mission critical business decisions for the enterprise. So healthcare and life sciences, preclinical, clinical R&D and drug discovery, better access to patient data, understanding of supply chain, same thing in CPG and manufacturing, whether they're quality, whether it's quality events, forensics, or supply chain traceability, or building out a digital twin of a vehicle. We work with a lot of automotive companies. In the same case, in banking and insurance, looking at non-financial risk and compliance, understanding from the front office perspective, the wealth managers and the customer 360 view, or just in the back office, understanding implications of assets and vendors, and where some PII data may or may not be located, and how that relates to certain risk policies that are evident inside regulated industries like banks, for that matter. So with that, I will transition into a demonstration of the scenario that I'm highlighting here in terms of the use cases. Let me escape out of this. There was a question from an individual. Will the slides be shared? Yes, absolutely. We will share these slides. And of course, more importantly, we'll share the recording here with this group. So, okay, so let's transition into a demonstration, a brief demonstration of our tech. I am pulling up a scenario where I am acting as the supply chain quality analyst. As part of a company called Good Beer Company, and as part of being part of Good Beer Company, I am responsible for looking at any quality event related issues that are happening in sort of post-market delivery of the manufactured beer. And the scenario here is that there has been reports about beer being reported flat at a particular ball field, in this case, Wrigley Field in Chicago, where the beer that was reported by consumers was reported as being flat. So again, in this interface, like any other conversational interface here, you kind of see a lot of similarities here, right? So the key here is the fact that the types of questions I can ask are in the context of my domain, and are limited to that domain in that sense that there's guardrails where I can't just make up answers or hallucinate. And the answers that I'm providing back are coming back from your enterprise systems. And I'll talk about that briefly as well. So let's take an example, Rick. So I'm asking the question, as the quality analyst, find all the consumers who provided feedback about flat beer. I can see that there were 3 consumers who provided feedback about flat beer: Charles Green, Polito Cow, and Isabel Jones. Maybe I want to follow that up and ask, which product brand was the feedback about? And again, this type of question and answering is what I would expect as the supply chain analyst who understands the domain context, because I may deliver multiple beer brands. And so the product brand for which the feedback was provided was Munich Dunkel. I may just follow up and say, okay, where did Charles Green purchase the beer? And you can kind of see that again, there's information that gets parsed from semantic. Now, in this case, what's interesting is I did not come back with this answer because I actually don't have that context. That's sort of in the guardrails of the semantic data model that I created now. So what's important is not only for us to be able to provide answers back to questions, but also not being able to create and generate an answer for which we don't have information that's mapped into the system here, right? So just as much as it's important for us to provide an answer, it's also important for us not to provide an answer where it doesn't make sense. Now I can continue this dialogue. I can look for more information. Maybe you want to show me distributors whose trucks and experienced an anomaly. And again, as I ask that question, I want to be able to say, okay, what's the answer to my question where I asked the distributors? I see there's one distributor whose trucks experienced an anomaly. In this case, it was Advanced Beverage. I can ask more open-ended questions. Tell me more about Advanced Beverage Co. Inc. And that open-ended question and answering says, yep, there is some entity that I can or cannot provide an answer. In this case, maybe I want to be able to see what's going on with this specific data set. And this is where I can have a bit more traceability behind the information that's being presented. So when I look at the actual data, that's sort of the lineage behind this information. And as I'm doing that, I'm actually also pulling in the semantic data model here. So what's happening behind the scenes is we're pulling together all the information related to that particular Advanced Beverage Co. Inc., where I can see the full traceability behind this. And I'm pulling into my semantic model in the interim. kind of show you how this works behind the scenes. What is driving this is this powered semantic model, right? So I've created a semantic model that's part of my knowledge graph to say that I have customer information located at selling points. Selling points deliver these skids or these pallets of beer. These beer get packed onto a truck have sensor information. And then from there, I can kind of see there's this an anomaly relationship that exists. But what's important is that I'm getting my information sourced against this semantic model from the enterprise source systems themselves. So for the customer information, I'm actually pulling that back from my Snowflake tables where I have customer information here, name, address, city, date, source ID, zip. From a sensor perspective, I have a lot of that information sitting in my sensor data in Databricks table, so I can view that. And I can see that I have things that are being captured in my Databricks tables. And so when I ask the question, what information is associated with the customer, we first of all identify the critical component of the semantic model we need to answer that question. And then based on the mapping that we have to the source system, we federate a query that's optimized for Snowflake. So we push a SQL query down to Snowflake, we push a SQL query down to Databricks, we get those answers, and then we summarize those results back in the response that you saw with Voicebox. And again, this is just an example of a handful of sources. We can connect to over 150 types of different data structures, databases, including Athena, Redshift, SQL, Postgres, Salesforce applications, Synapse, Trino. Again, these are ones configured in my system here. But the idea is that I can create this sort of semantic model and mapping back to your enterprise. And this provides not only the guardrails, but it allows me to track the lineage and traceability of the information here, right? So when I go back here, I see Advanced Beverage Company has 2 trucks associated with it. And I can see a little bit more information about Advanced Beverage Company here. It's a distributor, has an organization. Maybe I want to know more about this truck 002. I can kind of look at more details about that. Maybe I want to be able to expand that by, what else was packed onto the truck or what is being monitored on that truck. So let's say there were 5 skids that were packed onto that truck. These were the Munich Dunkel pallets, the Munich Dunkel beer brand. I can even have the dialogue that continues from here. So if I say which truck has an anomaly, and that allows me to understand a bit more details about, okay, I know there are 2 trucks associated with Advanced Beverage. I see that truck 002 has an anomaly. Or I may just ask, which vehicle has a problem. If I wanted to, phrase this a little differently, I can ask the same question, perhaps a little differently. And again, you can see that truck 002 has an anomaly is the response back. And what's driving that, the fact that my semantic data model here has concepts of trucks and anomalies, but what it does not have are concepts of vehicles and problems. But because we have an embedded vector search capability inside of Stardog, we're able to identify nearest neighboring concepts and identify the right component of the semantic model that is important in answering that question. And that's how we are able to generate those responses back in this particular scenario here, right? So again, I can kind of pull this context here about the truck and learn more about where that truck information is being sourced from, what is associated in terms of the specific connections there. And as I can pull that back here, you can kind of see there's 11 anomalous events that were associated with this particular truck. There were, 2 distributors. There were 3 finished products that were delivered. I can get more information. Maybe I want to ask, tell me more about truck 002. And again, the idea here is if there's information that I can get that is more sort of in the context of sort of natural language text conversation, that's one way. If I want to take a more of a graphical representation and explore further, that's another way I can go back and forth and ask those types of questions here as well. So there are more, you can see there are 55 vehicles with anomalies that have been reported. So I can kind of click on each of these events to try and get those answers back here. What's also important is this was sort of in the context of a supply chain scenario. If I wanted to change the business context to something different, let's say I wanted to move into in insurance, maybe perhaps a different scenario within the same organization, right? So it doesn't have to be a very specific, it doesn't have to be always about different industries. I may want to just say, okay, I want to learn more about the sort of insurance context here. So I'm picking an insurance model because I'm trying to understand specific claims associated with a particular individual, and I want to enable my front office staff to be able to best ask those questions in the context of insurance. So now I have these prompts that are provided to me where I can ask questions like, what is the most common loan term and how many people have such loans? So again, this is a little bit more of the calculated, aggregated question and answering that happens. I can see that the most common loan term is 360 months and 474 people have such loans. Or which customers have made more than one claim and what is the number of claims they've made? Again, now I've switched context. In this scenario, even though it's all in the same backend Stardog enterprise database, I can't ask questions about the supply chain, right? And the reason why that is because what was powering the supply chain question and answering was this semantic data model and these mappings. If I go back here in Designer, what's powering my insurance question and answer is this semantic data model and the specific data mappings associated with vehicles and customers and claims that come from a loan table or a customer table in order to service that particular knowledge worker with those types of responses. So that's the way you put not only the appropriate guardrails, but you're also in the best position to put the right security context on top of these domains where you can kind of have more information about a particular individual. So there's certain PII data that you don't want to expose, or there's information that you want to limit in terms of what gets presented back to a certain group of knowledge workers based on their role, their function in the enterprise. You're looking back here, back in the context of Designer, or even the context of beer scenario, supply chain, I have this notion of an anomaly. What's interesting is that anomaly is not something that actually exists in my data, but I have annotated that with business logic here. So I can I'm looking at the sensor data that comes from the Databricks, and I'm looking at what gets monitored on a truck. And any value that's greater than 55 degrees Fahrenheit is how I'm actually attributing this to an anomalous event. So this business logic is how I'm able to infer the fact that there is an anomaly in the data, not necessarily data that needs to be shaped in my tables or my underlying source, but this business logic allows me to put a new lens on top of the data, and I could put multiple lenses against the same semantic data model to serve different user groups, different personas in the enterprise, right? So then when I go back and ask questions like, not only which truck, maybe say, which sensor has an output of type anomaly, I'm able to ask and answer those types of questions as well. So multiple ways for me to go about answering those questions and being able to get these things in the right context as the user or the knowledge worker. I see lots of questions, and I answered one, like, how do you define anomaly? That was sort of the business logic that was indicated by the fact that the user wanted to attribute an anomalous event to anything with a temperature sensor reading on that particular truck was greater than 55 degrees. Can you link your semantic model to data in the graph database? Absolutely. That data not only has to be abstracted into connections and mappings into your enterprise systems, you can also have that semantic model against your materialized data in the graph database as well. Can you link? Okay, we talked about that. We talked about how do you define an anomaly. Let's see, can Voicebox as well do typical graph query like traversals? So you can absolutely see that. Not only are we trying to do things that are one degree connected, but the questions can be framed in ways where you can have multiple hops associated with it, right? So it's just a matter of how you frame the question. And then more importantly, you can also look at ways to use the power of inferencing to really shorten the amount of traversals you need to do. So you may be 2 or 3 degrees removed, but your inference logic allows you to create a relationship that's directed to answering the question where something might be 2 or 3 degrees removed from the original question as well. There's a question around how can organizations implement explainable AI frameworks to enable AI decision-making or transparent, especially in critical applications where AI's reasoning is essential. And again, my best answer, and of course, is a fairly broad response to this particular question. I would say that the best way to know is to put the right guardrails, and knowledge graphs enable you to put exactly that, right? So the right guardrails where you're not only able to define the context, the business context, but also limit where and to what extent question and answering can go for a given set of users. And then with the lineage of the information being mapped back to the source of the system, you have full traceability and explainability behind this. So what are we doing behind the scenes? We are using the power of large language models to generate a query. We are not using the large language model to feed it your enterprise data and rely on it for the truth of the answers, right? So our use of the knowledge graph, and I'll pull this back here, sort of discussing a bit more of the how, is essentially this particular flow, and I'll walk through that here now. So what happens is a user asks a question of Stardog. We identify critical business concepts and terms using the fine-tuned native large language model, if I can say that clearly. And then using that to our embedded vector search to identify the right component, the right pieces of the business ontology or the semantic data. Also adding to that fact that we are identifying the few shot examples in terms of how we use it for what we call dynamic prompting to give it some domain context, and then using those the right set of concepts in terms of the semantic data model that are relevant to answering the questions, and the few shot example to give them a bit more domain context. We use that to generate a query within Stardog. We then execute that query against the knowledge graph, which has the mappings back to your enterprise data, whether it's structured or unstructured. We then summarize that result back using the large language model and then presenting the answer back to the user. So there's full explainability, full traceability. There are no hallucinations. You put the right guardrails, and everything flows from a communication back and forth for the specific user and the user persona. Again, please use the Q&A section to ask any questions, and I'm happy to continue responding to them as they come up. That's the best way. Is very likely folks are using chat and QA both, and I might not be following everything that's going on, but hopefully that gives you a bit more color, and commentary and context into the actual inner working. Where again, what we have done the hard work of the large language model system integration, the orchestration, the deployment of the right GPU infrastructure to deliver the performance and the accuracy, and then more importantly, do it in a way that works best in terms of unit economics for us as well as our clients, right? So we're not beholden to OpenAI, and we're not beholden to AWS or Azure, even though we deploy on AWS, our cloud infrastructure. We're basically leveraging our infrastructure that manages the enterprise AI stack. And then we've done all the work to identify the best mechanism through which we can generate an accurate query to provide a response back to the user without having to physically move or copy their data and push that into the large language model. And then, of course, using the knowledge graph as the way to provide the guardrails and the business context to be able to answer questions from a business perspective. I see there are more questions here. Can you provide feedback to Voicebox if a response does not look correct? Yes. So there's a thumbs up, thumbs down kind of implementation with specific notification. You can add your own descriptors and descriptions into that. Let me if I pull back here. So for example, here, you'll see there's a thumbs up and a thumbs down. You can indicate whether or not you want to provide a response, and then you can provide more details about the response. Can you compare and contrast semantic data model with domain ontology? Is essentially one and the same thing, because we've built our platform on open standards for RDF and semantic web. The domain ontology basically is the representative semantic data model, i.e. the schema for which you put the right guardrails here. So we are interoperable with any external tool set that you built or used to build ontologies, whether you may be using existing tools or existing knowledge graph providers, and you've built an ontology within their layer. You can absolutely import that as the mechanism through which you can jumpstart the creation of the semantic data model here. For all intents and purposes, they mean the same thing, Steve. And actually, there was another question from Thomas. Are knowledge graphs connected with standard domain ontologies and our top ontologies? Again, the answer is yes. Obviously, what the purpose here for you to do is to ensure that whatever you're building is built in ways that is meaningful to answering the business questions. So when you look at designer, our purpose here is to enable sort of the semantic knowledge and understanding here, right? So when I look at consumer or customer, right? I have a full descriptor about what that means, or product feedback. These are the relationships, these are the attributes, these are the class concepts. And then what I'm really doing is mapping that back to my enterprise source systems. So if I see here, for example, data that I got to pull in from sensor data, I have the mappings defined in ways that I can kind of look at the information. I can use the power of Voicebox to even suggest mappings back from my technical metadata to my business domain ontology. And again, that automated suggested mapping is part of the feature of the product. Obviously, I'm not going to spend a lot of time on this right now, but know that we help facilitate the knowledge construction, the knowledge engineering process, along with the ability to enable sort of this question and answering through Voicebox as well, right? So not only that, if I go back here, one of the ways we actually even sometimes would recommend starting off is the power of knowledge, what we call our own knowledge catalog, where we look at harvesting all the technical metadata inside of your enterprise, and we can leverage and utilize existing data catalogs. So if you have, for example, if you have your business glossary in Calibra, we have the ability to bring that into Stardog. If you have your business glossary in Purview, we have the ability to do that. If you have your business glossary in Elation or even Unity, we can harvest the technical metadata and or business glossary and use that as ways to jumpstart your mapping and modeling process as well within Stardog. So that's an important distinction. I just wanted to highlight that. And you can kind of see here, Calibra, Atlan, Purview, Databricks, or frankly, any source that we can connect to, we will harvest the metadata and then start that whole knowledge construction, knowledge engineering process from that standpoint. Question about which LLM, not too relevant to this other than the fact that we're not using OpenAI. We do continue to look at the best open source LLMs. That's sort of the basis and foundation for the solution we've built. Everything from variants of Llama 2 to looking at Mistral now. We feel that we need to find the right large language model for the right instructions or the job that we need it to do. So almost an internally deployed multi-agent architecture behind the scenes, picking the right large language model. And frankly, when we say large language model, it may be a small language model if that does the trick for us. And that's part of the design pattern that we've built internally, and really looking to minimize any exposure of that work and put that burden on our clients. Do you use Stardog's own ontology editing tool or something else? We have our own. You saw Designer is the way you kind of build and construct that. If you have already built something external to Stardog, certainly you can bring that in. There's multiple ways you can do that. We have this notion of building a new project, and one of the ways is you can actually import your own ontology that's been built by an external tool. You can start from scratch. You go sort of bottoms up, which is one I talked about, leveraging your existing metadata in a business glossary, in a data catalog, or the schema ingestion that we do when we connect to your source systems, including the schemas, the primary keys, foreign keys, as the basis of helping you construct the knowledge graph. And then, of course, we're working very aggressively on a build it through a text chat communication way, build a knowledge graph using the power of Voicebox to not only answer questions, but also help you construct a knowledge graph. So more on that as we proceed in our roadmap. Is there a playground where I can use Voicebox with some demo data? Absolutely, Jesus. Please reach out to us, and we're happy to set you up with a playground. Maggie, yes, we have looked into small language models. In fact, like I said, we have done the hard work of working with the right language model for the job that we need it to do, right? So this is not about let's bring ChatGPT-4 and whether or not it makes sense in this context. Because remember, this is not about bringing the knowledge of the enterprise, the knowledge of the universe. This is about how do we fine-tune something that can generate accurately the query we need in order to execute against your enterprise data. So we've used the combination of large language models and small language models, 7 billion parameters, 1434, and we found the right mix in order to be able to respond to the needs of what we want in terms of the performance, the back and forth, the question answering, and of course the accuracy of the results. So lots of great questions. Hopefully I responded to most of you here. If I missed a few questions here and there, certainly feel free to reach out to me and our organization. Where I'll leave this with is, I know you guys, someone was asking, is there a playground to get started? What I would say is yes, there is a playground for you to get started, at least with experiencing the Stardog interface and the Voicebox interface on stardog.ai. Go ahead and sign up, and you will have access to the same environments that I just did from a demonstration standpoint. And then when you are ready to try something with your own data, certainly do ping us, and we'll be happy to set you up, particularly with an environment that's relevant here. So I do want to end with at least the fact that most of you, and some of you perhaps, were invited here with a specific value proposition in mind. In this case, a $100 Amazon gift card. And I do want to make the specific announcement of the winner. The winner of the $100 Amazon gift card for today is Maggie Roth from MasterCard. So Maggie Roth, congratulations. Jasmine will reach out to you shortly after today's session and send it your way. So thanks for attending. I see there are some questions here. Can things be done from on the chat window? My apologies. I was again focusing on the Q&A. I'll take a few more questions, Jazz, if we have a few minutes. How does Voicebox convert measures as tell me average amount of spend for a group of purchases when averages may not already be built into the data set? Exactly right. So those are computed query time. So you saw me say things like, tell me which claim, how many types of loans were associated with different types of claims. So a lot of those calculations happen at query time. Again, we have efficient ways to doing these types of calculations, including things like, how do we put things in cache so that there are some pre-calculated amounts that are ready to go from a caching perspective. That's a very common question. Or they can be part of the inferencing logic that I shared with you earlier as well. So a lot of different ways you can tackle that, Mark. Okay, I think we're at the we're almost close to the end here. Can Voicebox generate charts, graphs, or just text? Good news is we can definitely generate text. We are now enabling the next rev that's just coming out in a few weeks, where you can actually see tables of the information, especially when it comes to listing things. You'll see a table generated here, and that can be downloaded by the user and put into their favorite BI tool. More importantly, there is the direct ability for you to connect a BI tool directly against Stardog's knowledge graph, where we look like a SQL source to the BI tool of your choice, Tableau or Power BI. So that's another way you can generate more sophisticated charts and use it within the tools that you already have, rather than us trying to put some widgets here and there. But certainly something we're looking at keenly as we see demand for it within the context of Voicebox. All right, lots of questions. Let's see, I think we've answered a good chunk of these. If I missed here, is the data only internal, or is it looking outside the company's data? Again, it's whatever data you have access to that's been mapped against the semantic data model. So to the extent that you brought data into, a data lake somewhere, or time series database, or other sources of information that we can connect to, yes, we're not definitely not building pipelines into LinkedIn or Facebook. That's not the extent to what we're trying to do here. But if you have a lot of that enterprise data that has been blessed by the enterprise and that's sitting inside of your enterprise organization that we can connect to, then yes, absolutely, it can be part of the source of information that we can leverage. We talked about providing feedback. We can talk about, I think that's it. Let me see. Great webinar. Thank you. Appreciate it. Thanks, guys. I think we'll end here. Otherwise, I'll keep going. I'll give you back 10 minutes of your time. Cheers.